Okay, in this lesson I'm going to be teaching you how to find the x and the y-intercept of a graph. And in this lesson, it's important that you understand these three little stars here. The x-intercept is where y is equal to 0. The y-intercept is where x is equal to 0. And if the x and the y are on the same side, then the cover-up method is the best way to find the x and y-intercept. And I'm going to spend some time talking about these three, but this is the key to this entire assignment. In fact, these first two, if you can memorize these first two, you pretty much have everything you need to know for graphing. So with that being said, let's go ahead and try an example so you can see this. Now, before I even get started there, I want you to understand what an x and a y-intercept are. If I was to look at a coordinate plane, an x-intercept is, remember these are lines, right? And the x-intercept is wherever it crosses the x-axis. So let's say if I graphed the line and it crossed there, okay? Or let's say I graphed it a different time and it crossed there. Wherever it crosses the x-axis is called the x-intercept. Well, let's name these points. Any point that it crosses the x-axis, what do they have in common? Well, let's graph this. Let's name this point. This is what? Negative 5, 0. Name this point 2, 0. Name this point 6, 0. Any point that is on the x-axis has something in common. All of them have y equals 0. So that's what I was saying a minute ago. The x-intercept is where y is equal to 0, right? And the y-intercept, if I was to graph some points, the y-intercept is wherever it crosses the y-axis. Any point that it crosses the y-axis, what do these points have in common? Well, this is 0, 9. This is 0, 7. And this is 0, 6. And even if I put a point down here like this one, this is 0, negative 6. But any point that it crosses the y-axis, what do they all have in common? Well, the x's are 0. So the x-intercept, y is 0, and the y-intercept, x is equal to 0. All right? We're going to use those two things to our advantage. So what you're going to do, to find the x-intercept, you're going to make y equals 0, and then you're going to solve the equation. So you're going to get 2x plus 3 times 0 equals 12. So 2x plus 3 times 0 is 0. So this becomes 0. So this is basically gone. And you're left with 2x equals 12. And you need to solve that. Divide by 2, divide by 2. X is 6. So what am I saying? The point that this graph, and remember this is a graph of a line, the point where this graph crosses the x-axis is point 6, 0. So if I was to go back over here, and I was to graph that point, 6, 0, 6, 0 is right here, right? What does that tell me? I now know one point that is on the line, okay? So I graph 6, 0. That's one point that I know on the line. Now to find the y-intercept, I make x equals 0 because remember, wherever it crosses the y-axis, all the points that cross the y-axis have something in common. X is 0. So what I'm going to do is I'm going to do the same problem again, but this time I'm going to make x equals 0. So it's going to be 2 times 0 plus 3y equals 12. All right? Well, 2 times 0 is 0, so this goes away, and I'm left with 3y equals 12. So divide both sides by 3, and I get y is 4. So the name of this point is x was 0, y was 4. Now what's interesting about this, when you graph those 2 points, I graph the x-intercept, 6, 0, I graph the y-intercept, 0, 4, which is here. I now have enough information in which to graph the entire equation. So I have enough information now, to graph the entire equation of the line. Let's try this one more time. So there's the equation of my line. I really like graphing linear equations using the x and y-intercept because you can get these 2 points really quickly. It's quick math, and you can quickly get the equation of a line. Because remember, you don't need 5 points to find what the line looks like. You really only need 2 points because 2 points make a line. So you can quickly find those two. Now, if you go back into your notes real quick and you look at it, I say use the cover-up method when the x and the y are on the same side. So let's look at this equation right here. 2x plus 3y equals 12. Are the x and the y on the same side? Yes. So when you want to use the cover-up method to solve these, this is what I want you to do. If you want to find the x-intercept, you cover up the y, and you're left with this equation. 2x equals 12. Because the y goes away because remember it made 0. So we have 2x equals 12, so what's x going to be? 6. It's really quick. So x is 6. To find the y-intercept, you cover up x, and you're left with 3y equals 12. So y has to be 4. So when the x and the y are on the same side, the best way to do this is to cover it up. And I would use my finger to do that. On your notes, obviously, I can't use a finger when I'm doing this video lesson, but with on your homework, just cover it up with your fingers. To find the x-intercept, cover up the y. To find the y-intercept, cover up the x. And that's exactly how I'm going to teach you how to do this in your notes. So let's go back to our notes. All right, so to find the x-intercept, remember y is 0. To find the y-intercept, x is 0. And if the x and y are on the same side, then use the cover-up method to find the x and y-intercept. So let's go to this first one. Notice here, and you can see this in this notes, and I will fix this in your class, but these are actually flip-flopped. That's a real bad no-no. This is actually 0.30. Oh my goodness, messing that up. This is actually 30. Okay, this is getting annoying. All right, so 30, erase all that, and this is actually 0.4. So go ahead and fix your notes. So y-intercept is wherever it crosses the y-axis, and that's a point 0 comma something, and the x-axis, the x-intercept is wherever it crosses the x-axis, which is 3 something. Okay, so go ahead and fix your notes on that. All right, so let's find the x and the y-intercepts of this equation and graph it. All right, for the first example, I'm going to do it the long way, which is to do it like this. To find the x-intercept, this is what I want you to do. To find the x-intercept, you say x-intercept, and then you write y is equal to 0, and then you solve it. 3x minus 2 times 0 equals 12. Well, what happens? This goes away. I'm left with 3x equals 12. Divide both sides by 3. I get x equals 4. So the name of this point was 4, 0. So that's a point on this line. 4, 0 is right here, correct? All right. To find the y-intercept, you need to write y-intercept, and then you need to write x is equal to 0. I want you to write this every time because it's going to help you to get it stuck in your head. So let's go ahead and do that. 3 times 0, because now x is 0, minus 2 times y is equal to 12. Well, 3 times 0 is 0, so this goes away. That's still negative, so it's negative 2y equals 12. So divide both sides by negative 2. And y is a negative 6. So what's the name of this point? 0, negative 6. The x-intercept is 4, 0. The y-intercept is 0, negative 6. Let's go ahead and graph that. 0, negative 6. I have 2 points. 2 points make a line, so I'm going to go ahead and make that line now. Like I said, yours should be a little bit better than mine. But there's my line. Quick way to graph it. Now, let me show you again using the cover-up method. How could I have done this with the cover-up method? Well, to find the x-intercept, all I would do is I would use my finger and cover up the y. So I end up with 3x equaling 12, so x is 4. To find the y-intercept, I cover up the x, and I'm left with negative 2y equals 12, so y is negative 6. The cover-up method is the way I would have you do this pretty much every time. All right? So now let's do example 2. Okay? Now in this case, if the x and the y are on the same side, I want you to start using the cover-up method. Okay? If the x and the y are on the same side, use the cover-up method. Are the x and the y on the same side? Yes, so let's use the cover-up method. So all I'm going to do to find the x-intercept, I'm going to write x-intercept, y is equal to 0, and yes, you must write that, but you can use the cover-up method to solve it. For the x-intercept, you cover up the y, and you're left with x equals negative 12. So there's my x-intercept. X is equal to negative 12. So what's the name of that point? Negative 12, 0. Okay? To find the y-intercept, I make x equal 0. Right? So when the x and the y are on the same side, you can cover it up. To find the y-intercept, you cover up the x, and you're left with 4y equals negative 12. So 4y equals negative 12. If you divide both sides by 4, negative 12 divided by 4 is negative 3. So the y-intercept, y is equal to negative 3. So the name of that point is 0, negative 3. And if you want to see how I did that again, all I would do is, if I take away my little my square here, if I have x plus 4y equals negative 12 and I make x 0, I'm basically left with 4y equals negative 12, and that's an easy algebra problem to solve. Okay? Now we go ahead and graph those 2 points. Graph negative 12, 0. Well, negative 12, 0 is going to be about right here. And 0, negative 3 is about right here. And then I go ahead and make that equation of that line. Oh my gosh. Let's fix that. What was it? Negative 12, 0. And 0, negative 3, right? Let's see if I can make this correct this time. All right, and the graph of the line is going to look something like that. And there you have it. All right, one more example. Okay, in this case, the x and the y are not on the same side, so the cover-up method is not going to work as well. You could still use the cover-up method, but it's not going to work as well because when you cover up the y, you end up with an equation equaling 0, and it's not as easy to do. So when the x and the y are not on the same side, what you're going to have to do is solve it the other way. All right? So to find the x-intercept, x-intercept, you make the x-intercept, y is equal to 0. For the y-intercept, x is equal to 0. So to find the x-intercept and make y equals 0, you get 0 equals 2x minus 3. Bring the 3 over, add 3 to both sides, right? We get 3 equals 2x, divide both sides by 2. We get x is equal to 3 halves, which is 1 1/2. So the x-intercept is 3 halves, 3 halves, comma 0. Boy, that is really sloppy, isn't it? The x-intercept is 3 halves, comma 0. The y-intercept is actually really easy here because when you do that, you're going to make x equals 0. So you're going to get y is equal to 2 times nothing minus 3. So y is equal to negative 3. So to name this point, for the y-intercept, The name of that point is 0, -3. Go ahead and graph those 2 points. Remember what 3 has is it's 1.5, so 1.5, comma 0 is here. And 0, -3 is here. There's my 2 points. Let's make a line out of them, right? Wow, that gets annoying every time I do that. Going through there, and going through there. And there you have it. There's the graph of your line. All right? That's the X and Y intercept, how to graph using the X and Y intercepts. They are two of the most important points on your graph. Lots of good information comes from them that we'll be covering in later lessons. But hopefully from now on, when you see an equation where the X and the Y are on the same side, you can quickly graph that using those 2 points. All right? Good luck with this.